Hi, I'm Dave, and I love making combat robots. And today I wanted to share with you a few of my rules of thumb that I use when making my next robot build. So if you're making your next combat robot, have a look and see what you think. If you're an old hand at making combat robots, take a look. Maybe make some comments where you agree or disagree with some of my rules. Okay, let's talk about three areas today: the drive motors for the robot's weight distribution, and armor materials and thicknesses. So looking at the drive motors, I'm going to talk about the different weight classes going from 150 grams, which is the ferry weight, all the way up to the Doge weight, which is 15 pounds. In the ferry weight class, really you're going to see most often N20s. It's a small gearbox that's perfectly suited for driving those small robots. In the 1 pound range, I'm usually looking at Fingertech, Silver Sparks, or you could look up a generic 16 millimeter gear motor. The Fingertechs have a much longer axis, and you have a little bit more flexibility there. The generic 16 millimeter gear motors, I always find their axle to be a little bit too short for me. You can use these in the 3 pound, even though they'll be a little bit underpowered, and they definitely need some supports there if you're going to use them in the 3 pound. And if you use them in the 150 gram range, they're going to take up a lot of your weight allotment just in the motors. Moving on to the 3 pound, again, you're using gearboxes that are a little bit bigger. I'm usually looking at between 22 millimeters to 25 millimeters or 1 inch gear motor. And of course you can buy them combined already, like the bot kits motor as a brushed, or you can combine it with a brushless motor. Now you can use these in the 1 pound area as well, but again it becomes a little bit overkill. You'll definitely have the torque advantage on every other bot, but your weight allotment for your weapon is going to be a lot less. In the 12 to 15 pound range, I'm usually looking at a 550 motor. I'll either combine that with a Bainbot's planetary gearbox, or I've also used the planetary gearbox you can get out of drill guns. In those cases, you can buy the the drill gun and pretty much get the motor combined with the gearbox right out of the unit. You do want to look ideally for planetary gearboxes that have metal gears there because they're just a lot more robust and less likely to break. Now talking about how you're going to attach your wheel to the chassis, basically it's perfectly fine, I think, to do a direct mount when you're looking at the 150 gram to the 1 pound range. I usually start getting a little bit reluctant to do a direct motor on the 3 pound just because it's so destructive, that weight class. And then definitely in the 12 to 15 pound range, you need some sort of support, extra support for the axle and the wheel when it gets hit or when the robot gets thrown into the air. Or you need to do some sort of belt to transfer the rotation to a separate shaft. When looking at motor RPM, it's important to note that any given robot, the speed will vary even if you have the same RPM on the motor. Using a larger wheel is going to give you more speed, but it's going to reduce your torque somewhat. You can increase the speed with higher voltage. I generally find that as a base motor RPM, though, I usually like to find something in the 500 to 800 RPM range. That definitely gives me some working space if I need to go with smaller wheels or with different voltage. But generally, if I'm in that 500 to 800 range, usually I have no problem using that motor and being fairly zippy. Obviously on the 800 RPM range, you're probably going to be one of the faster robots in the arena. When looking at making a combat robot, I like to divide the entire robot into 3 systems: the weapon system, the chassis, and then the drive system. I like to keep the weight about 1/3 in each, at least to start. That kind of gives me a starting point. Obviously, if I need to up the amount of weight in any one system, I can do that. I just have to realize that it's going to cost me in one of the other areas. Talking about weight distribution, I'm thinking mostly about the most common form of robot, which is a two-wheel drive bot that has basically a wedge or some other weapon in the front. You're going to have your weight distribution between those 2 points, basically the front of the bot and where your motors are. The front weight is usually going to be comprised mostly of the weapon and the armor, while the back, where the wheels are going to be the drive system and the electronics. But you want to keep the weight more or less even between these two areas, because if you don't, you end up with too much weight in the front where the weapon is, and you'll lose a lot of your traction. Take a look at Stump Grinder in the Maker Faire 2019 combat robot event, where Robot Ruckus, where we had some issues with the levelness of the floor, and that resulted in us crab walking. Likewise, when we're talking about weight distribution and wheel traction, the example shown here is good. You have both wheels are touching the floor. Eventually there's going to be a point in the front of your robot that's touching the arena floor. Ideally you want that to be one location. What's bad is if you end up with two locations that define the plane on the front of the robot, and that means you end up with just one wheel touching the floor. And this will automatically turn you into a crab walker. Okay, I just going to go through some of the armor material options and the thicknesses I like to use. Generally, I don't recommend ABS or 3D printed materials, PLA. In most robots, maybe in the 150 gram, it's okay for armor. I try to avoid it. If you're going to use it, definitely use 100% infill though. Polycarbonate though is a really good material. It comes in a lot of different thicknesses, which makes it usable across all the different robot classes. It's readily available at places like Home Depot. I think twice about using it as my main armor on the heavier bots, the 3-pound and the 12 to 15-pound range. I'm more likely to use high-density polyethylene or ultra-high molecular weight. Those come in nice sizes, suitable for the 3 and 12 to 15-pound range. In a thinner stock, it tends to warp more, so dimensionally stability isn't that great, so I don't use it that often in the lighter classes. For carbon fiber, I've had a lot of good results in using 2 or 3 ply vacuum-formed armor sheets that I make either in the shape of the robot or as plates. I would think twice about using it in the 3-pounder as my main form of armor, and I'd probably be looking at using at least 3 millimeters or 1/8 of an inch. Likewise, I don't use aluminum in the 12 to 15 pound. It's just, as armor, it's a little bit too soft. Opponents' weapons can dig into it really well and throw you around. So I'm more likely to use steel. But if I am going to use steel, I'm probably looking to use that AR 400 or 500 because it's a lot better for impact resistance, a lot less likely to bend. But you have limited thicknesses as an option. It's hard to find it under than 3/16 of an inch. However, titanium comes in a lot of different sizes, and I use it. It's great across all the different combat robot sizes. You know, starting with a 1/2 millimeter that I'll use sparingly in the 150 gram weight, all the way up to what I'm currently using is 1/8 inch in the 15-pound range. I'm not sure if that 1/8 is going to be enough against all different kinds of weapons, size weapons, but I'm hoping that that's good enough. 1/16 inch is not quite enough. Okay, so to wrap that up, you've seen a little bit of my rules of thumb for the different motor sizes, for the weight distribution, and for armor materials and thicknesses. I hope that can help you in your next combat robot build. Thanks.